Hello, this is Dr. K. Welcome to this series of videos on Java linked lists. In a previous video, we talked about arrays and array lists, and I showed you this diagram that gives you a small subset of the Java type hierarchy. As a reminder, all the arrows here are is-a relationships. So array list is a kind of abstract list, and abstract list is a kind of list. The solid arrows denote an inheritance relationship, and the dashed arrows represent an implements relationship. In this module, we're going to get into the other major implementation of lists, the linked list, which you can see here on the bottom right of the page. We've already talked about the distinction between interfaces and implementations. Your view of the DVD player and your mental model about how it's supposed to work constitutes its interface. And the internal workings of the player is its implementation. Remember that the same interface can have multiple implementations associated with it, as long as those implementations don't change how the DVD player behaves. The same is true in software. The list interface you see here consists only of method signatures, not bodies, and you can check the Java docs to see how those methods behave. But there are two popular implementations for the list interface. One we've already talked about, and that's the array list implementation. As the name suggests, Java uses an array in the code for the array list. Here's how we would declare a list of strings in Java that was implemented with an array list. Notice that we declare S as a list and initialize it with an array list. The other commonly used list implementation in Java is the linked list. Linked data structures typically make use of nodes to hold their data, and these nodes will point or link to other nodes. It's not that different from web pages that link to other web pages. Here's how you declare a list in Java that's implemented with a linked list. You can see that it's exactly like the previous declaration, except that we're initializing the list with a linked list instead of an array list. So now the big question. If the array list and linked list make the list object behave in the same way, why have two different implementations? Please pause the video and see if you can answer this important question. Ready? Many of you probably know this one already. The answer is that although their functional behavior is the same, their performance behavior is different. Think of what we can do with a list object. We can add elements to it, remove elements from it, we can access and update the list elements. It turns out that if we need to quickly access or update an element in our list without removing it, we're better off using an array list implementation, because arrays are really fast at accesses and updates. However, if we anticipate having to insert and remove elements from the middle of a list a lot, then we're probably better off using a linked list implementation, because it takes constant time to insert and remove elements from a linked list. So the functional behavior, the behavior that makes a program work correctly or not work correctly, does not change between implementations. But the performance behavior, the behavior that makes a program perform slower or faster depending on the situation, will change between implementations. Let's remind ourselves of what an array-based implementation looks like. An array-based implementation uses a partially filled array to represent the list. The initial array can only hold a fixed number of elements, but a size variable keeps track of the number of elements that the list has. The indexes of the array always correspond to the indexes of the list. An empty list will look like this. This array can hold 10 elements before it reaches capacity. Since lists do not have a maximum capacity, something needs to happen when the capacity of the array is reached. If I give you 10 seconds, can you tell me what that something is? 10 seconds starting from now. Okay, a brand new array object is created that is double the size of the original array. The contents of the original array are put into the new array, and the instance variable named elements is redirected to the new array. So now additional elements can be added.